Hi, today we're going to look at linear equations and their graphs. A linear equation is a sum or difference of terms that are either constant or a coefficient times a variable. So here's some examples of a linear equation. And here are some examples that are not linear equations. We've got xy equals z. We have x times y, so a variable times a variable is not linear. And then we've got y equals 5x squared minus 3. X squared makes it not a variable. Makes it not a linear equation. And then t equals 3 divided by v. Since v is in the denominator, it makes it not linear. A solution of a linear equation is a point, typically denoted by x comma y, but it doesn't have to be x's and y's. It can be s's and t's, u's and v's, right? It can be any variables. But it is a point, so you've got two values, an x and a y. That satisfies the equation. So we're going to do a couple examples of just answering the question, is this a solution to the equation? So we're given an equation, 3x plus 2y equals 3, and we're given a point, 1 comma 0. So what I do to figure it out is I plug in my point, making sure to plug in the x for the x and the y for the y. So 3 times 1 plus 2 times 0 is 3. So yes, it is a solution to the equation. B, 3x minus 6y equals 27 for the point 11 comma negative 1. So I'll plug it in, and then we need to figure out what is 3 times 11 minus 6 times negative 1. Is it 27? It is not. So this is not a solution to the equation. And then C, y equals 5x plus 2 for 1 comma 7. So I'm going to plug in the x value, 5 times 1 plus 2. Does that equal y, which is 7? Yes. So it is a solution to the equation. The next thing we're going to look at is the slope of a line. The slope is generally denoted by the letter m, which stands for the Greek word for mountain. And the equation is y2 minus y1 over x2 minus x1. It doesn't matter which of your points you call x1, y1 and x2, y2, as long as they line up. So as long as the 1's are being subtracted and the 2's are the first ones, doesn't matter. This is also sometimes called rise over run, which we're going to use later when we talk about graphing. And slope is a measure of steepness. If m is positive, that means that the line is increasing. If m is negative, then that means that the line is decreasing. M is 0 means that the line is horizontal. It means there is no rise. So it's just running, it's just flat horizontal. The higher the slope, the steeper the line in positive or negative direction. So if absolute value is bigger, then the line is steeper. So we're going to do a couple examples of just finding the slope between each pair of points. So we've got the points 2 comma 0 and negative 3 comma 4. So m equals y2 minus y1 over x2 minus x1. And that is negative 4 over 5. And we've got 0 comma 2 and 3 comma 2. Slope is 2 minus 2 over 3 minus 0, which gives us 0. Let me try another one. Negative 2, negative 1, and 2, 1. So m is 1 minus negative 1 over 2 minus negative 2, which is 2 over 4, and we always need to simplify our slopes. So 2 over 4 is 1 over 2. Okay, so we've talked about linear equations a little bit in general. We've talked about the slope, and now we're going to look at graphing. So we're going to graph using two different methods. The first one is graphing with slopes. And we're going to look at what's called the slope-intercept form of a line. So y equals mx plus b. M, again, is the slope, And B is the y-coordinate of the y-intercept, which is the point 0, B, where the graph crosses the y-axis, which is when x is 0. So our first example is going to be y equals 2x minus 3, and we're going to start with the y-intercept. So in our case, the y-intercept is negative 3, and I'm going to plot that point, 0, negative 3. And then I'm going to look at the fact that my slope is 2, and 2, my slope, remember, is rise over run. So I'm going to rewrite my 2 as a fraction, and I can use any fraction that's equivalent to 2. The most obvious one being 2 over 1. So I'm going to rise 2 and run 1. So I go up 2 and over 1, and my new point is roughly right there. And then I can do it again. I can go up 2 and over 1. Nah, that was wrong. Up 2, let me rewrite the first point. Up 2 over 1, up 2 over 1. There we go, much better. I could also, if I wanted, rewrite 2 over 1 as negative 2 over negative 1. And then I could start back at my y-intercept and go down 2 and to the left 1, which would be roughly right there. Once I have 3 or 4 points, I can connect them with a line. I always want to do at least 3 points because any 2 points will give me a line, and I want to make sure I have the correct line. So I will do at least 3, sometimes even 4 points. But there's our first example. For our next example, we have y equals 1/2 x. So if we look at our equation, we want to figure out what b is. So there is no b, so b is 0. So our y-intercept is the origin, 0, 0. And then we look at our slope, and we have 1/2. And again, that's rise over run. So I'm going to rise 1 and run 2. So rise 1, run 2. And again, I can do it again. I can go up 1 and over 2. Or I can think of it as negative 1 over negative 2 and go down 1 and to the left 2. Okay, so any form that's equivalent to 1/2 I can use. And again, once I've got 3 or 4 points, I look at them and I say, yep, that is a straight line, roughly. I will connect them. Okay. We'll do a couple more using this method. So y equals negative 2/3 x plus 1. So our y-intercept is positive 1. So I get a point right there. And then we're going to look at the slope. The slope is negative 2/3. So negative 2 over 3. So again, that means I am going to rise negative 2, which means go down 2, and run 3. So down 2 and to the right 3. Or I could again switch it and say that it's 2 over negative 3. So instead, I could have gone up 2 and to the left 3. And again, as soon as I've got at least 3 of them, I can connect them with a straight line. And that was not a very good line, but we can see where it should have been. Okay, so we got one more that we're going to do using the slope intercept. Y equals 4. Okay, so we can always write 4 as 0x plus 4. So slope is 0, and 4 is my y-intercept. So again, I'm going to start by plotting my y-intercept, which is 4. 1, 2, 3, 4. Slope is 0. 0 I can write as 0 over anything that's not 0. So for instance, 0 over 1, or 0 over 3, or 0 over any number. Again, that's not 0. Which means I'm going to rise 0 and run so many numbers. So I can go by 1, I can go by 3, I can go by any amount. And if I'm not running at all, then I'm staying at 4. And this will give me, when I connect them, a very nice, assuming I do it correctly, horizontal line. So y equals 4 is the horizontal line at the height of 4. No matter what x is, y is 4. So now we're going to look at the other way that we tend to graph equations, which is graphing using the intercepts. We've talked about the y-intercept a little bit. It's the point 0, b. So x is 0, and then we can solve our equation for for y if it's not in slope-intercept form. And the x-intercept is a, 0, where we set y to 0 and solve for x. What we do then is we find the intercepts and we graph them. Assuming that they're not both 0, 0, we can then connect the points with a straight line, because remember, any 2 points will create a line. So for our first example, we've got y equals 4x minus 8. I plug in x is 0, and I get out that y is, that should be negative 8. Negative 8. Keep putting that negative sign back there. So this is my y-intercept, 0, negative 8. And then we've got plugging in that y is 0. So 0 equals 4x minus 8. And if we solve that, we get 2, 0. So we have our 2 points, 0, negative 8, and 2, 0. So I'm going to graph those two. So 0, negative 8, roughly, and 2, 0, again, roughly. Those 2 points will create a line. So all I have to do is connect them. I'm going to try to make it straight. Close enough. Okay, so that's all we have to do. So let's try another one. 2x plus 3y equals 6. I'm going to first plug in 0 for x, solve it for y. I get 0, 2. And then I'm going to plug in that y is 0 and solve for x. And I get 3, 0. So I'm going to plot them. I have 0, 2, and 3, 0. And then I will connect them again with a straight line as best I can. And that's close enough. Let's try another one. Graph the following using their intercepts. Y equals negative 2. If x is 0, y is negative 2. However, I can't plug in y as 0 because 0 does not equal negative 2. So there is no y-intercept. So I've only got 1 point, which is the, oops, that's bad, 0, negative 2. Because I don't have another intercept, I can't really graph using the intercepts, but if I remember from a previous example, y equals a number is just the horizontal line at that number. So I have a horizontal line at negative 2. And as our last example, we've got negative 5x plus 10y equals 5. So I'm going to plug in 0 for x and solve for y. And I get that y is 3/2. And then I plug in y is 0 and solve for x. And I get negative 3. So I'm going to plot my negative 3, 0. Pop that a little better. And then 0, 3/2. So remember, 3/2 is 1.5. So somewhere between the 1 and the 2. Again, I've got 2 points. I can connect them with a line. And there is my graph. Okay, so try these out. Let me know if you have any questions, and good luck.